Hello, my name is Sandra, and this is my project, Real-Time IoT Monitoring and Dashboard System on Azure. The goal of this project is to build a complete end-to-end cloud system that simulates IoT sensor, sends live telemetry to Azure, processes the data in real time, stores it for analysis, and displays it on a responsive dashboard. In this video, I will walk through the architecture, show the live system running, demonstrate the dashboard, and briefly explain the main code component. Here is the architecture diagram of the system. The flow starts with the sensor. The flow starts with the sensor simulator. So they generate random telemetry such as temperature, humidity, um, and a timestamp, snow accumulation, and so on. And these messages are sent to Azure IoT Hub, which act as the secure ingestion service for device-to-cloud communication. From there, a Stream Analytics job receives the data in real time. Stream Analytics performs two things. One, it processes data into Cosmos DB, which powers the live dashboard. This and two, it archive every raw message into Blob Storage, while the data is kept for future analytics or backup. Finally, the data is displayed in my dashboard web app, which fetches data from API. This dashboard shows real-time value, historical trends, and safety indicator based on sensor thresholds. And this architecture follows Microsoft recommendation pattern: ingest, process, store, visualize. Help on metrics, you can see that the number of telemetry messages is increasing in real time. This confirms that the simulator is successfully sending data. Next, let's go to my Stream Analytics job. Here under monitoring, you can see incoming events, output event, and the job overall status. This is input event. This is output event. Now I'll show my Blob Storage account. Under my container, you can see files being created automatically. This contain raw archive telemetry for long-term storage. Here is my Cosmos DB container. The documents are updating live as data is processed. Every new sensor message becomes a new entry in the database, which the dashboard can query instantly. And finally, here is the dashboard. The real-time value update automatically. The safety indicator shows whether the environment is safe or if thresholds are exceeded. The historical charts there let you visualize trends over time. The dashboard also refreshes automatically every few seconds. Yeah. I will now highlight the key parts of the code. we are in the sensor simulation suite. The Python simulator generates the random sensor values and send them to the IoT Hub using the IoT Hub device SDK. The important parts are first, establishing the device client connection. There it's load environment variable from .env file. There you have the device configuration, the ID, the location. Then it creates clients. Next, it generates a realistic sensor value. Then it returns device ID, location, eye thickness, surface temperature, snow accumulation, external temperature, and with timestamps. And finally, when we start the simulation for every entry in clients, it sends the payload it created. So we simulated the payload. It sent this payload, or it sent JSON formatted messages with timestamp. For example, we have sent the device ID and all the payload there. For stream analytics query, my stream analytics query reads from IoT Hub and performs two outputs. One query insert processing value into Cosmo DB. Another output archive raw JSON file into Blob Storage. So it selects all the payload generated by the simulator from IoT Hub input, and it selects it determine or define the safety status, like safe when average eye thickness is over 30 and average surface temperature is under -2, it's safe. When average eye thickness is over 25 and average surface temperature is under 0, it's caution. And for other configuration, we have unsafe status. Then it select explicitly configuration or information to send to Cosmos DB for this output, Cosmos output. And for Blob, it select all. It's almost the same thing. It was just a problem with the query, but it selects all and send it into the output Blob output. The Node.js Express IP expose endpoints such as API latest to get the most recent sensor reading, API history for those, like for example, to get historical data, and optional status. We have the overall status endpoint. The dashboard fetches this value through Ajax, or fetch request and updates the UI like this automatically. And there we have our dashboard with the cards, with the overall status, and with the charts.